Hello, Keith Rucker here at VintageMachinery.org. Guys, today we are back to working on the Amazon cane mill, John Deere cane mill that we started working on a while back. And in a previous episode, we had gotten this big main crushing drum up onto the lathe and was getting ready to start looking at it and realized we had some serious issues with this wheel. And talking to the owner, he had already warned me that he thought this drum was undersized, and found out that after doing some work that back in the 1980s, somebody come in here and tried to rebuild this drum and didn't do some things probably the way they should have been done. And one of the big things they didn't do, they didn't make the drum big enough in diameter, and because of that, it was causing them trouble. We talked about, how we might go around trying to fix this, and ultimately what we decided was to just make a whole new drum, to cast a new drum, to start from scratch and do it right and have something that's going to be the way it needs to be done. Could we salvage this? Yeah, it's probably doable, but it's probably not the ideal way of doing things. So we're going to, just like I said, we're going to make a new casting. So in order to make a new casting, we have to have a pattern. Patterns are basically what is used in the foundry to put into the sand that they make the mold around. They pull the pattern out. That leaves basically the void inside the sand where they can then pour the molten cast iron to make the casting. It's an art that has been going on for centuries. And honestly, in today's society, we don't do a whole lot of cast iron casting, not like we used to. Things now are made out of plastic rather than cast iron. From back in the day, they tend to make more things out of cast iron. Also today, things are fabricated, made out of steel and stuff like that. In some cases for the better, in some cases for the worse. Big reason they just don't do the cast iron is because there's a lot of work to it. And you can usually get by and do it cheaper, maybe not better, but cheaper. We are going to make a cast iron new drum for this, or at least the drum part will be cast iron. So what all is involved in this? So we got to make a split pattern, and this is a fairly complex part that has to be done. It's not your average everyday casting. Number one, the drum is cast iron, okay? The shaft is steel. So basically what they did is they took a piece of steel shaft and they put it into the mold and they poured the cast iron around it. I'm sure that if we were to go in here and tear this thing apart, which we're not going to do, you'd find that they probably milled some keys in there so that the cast iron would actually flow down in there and it would be keyed in place. And when that cast iron shrinks, it's like a press fit around it. When it shrinks as it cools, it will actually tighten up on there and make a very nice fit. No need for welding or anything like that. It's not really fused to it. It's just kind of shrunk in place around it. And again, if you've got some keys in there, that molten cast iron will go down there and it'll actually form a key in there and everything's good. And that's what we're going to do. We will make a new shaft. We'll put it into the mold. Now, when I make the pattern, we got to go ahead and make the print, or the pattern will actually have the shaft in it. It'll leave the void in the sand, but before we pour it, we'll drop the shaft into those prints. That's almost like a core print. Another interesting thing that really kind of makes this pattern a little bit more complicated than your average pattern is that the center of it is hollow. It's been what they call cored out. And the way you do cores is you have a sand core that actually goes in it inside, and that kind of complicates things as well. I've studied this casting and I think I've got a pretty good idea how they made it originally. And kind of unusual, normally when I make patterns, they're two-piece patterns, sometimes a one-piece pattern. You can just put it in there and pull it out. Most patterns are split patterns. You have two pieces, one the top and the bottom. You separate your mold, you pull the two halves out, you put the mold back together, and you got your part. But because of the way that this particular casting needs to be done, and I've talked with my foundry, Clark, over at Windy Hill Foundry, we really need to pour this up and down. So instead of horizontal like it is now, pouring it vertically, where the shaft is going straight up and down, basically you'll pour into the bottom, this will be the top. And it's going to be important to do it that way because of the cores. The cores need to be sitting down on something to support them, because there's basically going to be some sand disc that will drop on the inside of this. And when we pour that, of course, the iron won't go into that area. Then you chip out all the old sand, and you got a hollow on the inside, which is the way this one is. So this is going to be a three-piece pattern. We'll have the bottom half down here will be a split pattern, a top and a bottom. We'll fold it up, and then there will be a third piece that will actually fit on the top. That'll be this top piece up here that kind of caps it all together. Yeah, kind of complicated. It's hard for me to describe it, but as we build this pattern, I think you'll get a better understanding of how it's all going to come together. Additionally, in addition to making the pattern itself, we're going to actually have to make a custom cope and drag the actual box that this is going to be molded in to make it all work out right. And again, I got in my mind how I want to do it. We just got to build it. And today, that's what we're going to get started with. Now, traditionally, patterns were made out of wood. Sometimes you would make the original pattern out of wood, and then you might cast it in aluminum or something if it's going to be a production pattern, and then cast off the metal pattern, but you would have the original wooden pattern as your master pattern that you go back to and make more production patterns as needed. If you were doing a fairly small run, you would just use the wooden pattern. And in a lot of cases, they only use wooden patterns. That was all that they used were wooden patterns. The wood that was commonly used, pretty much about any kind of wood you can think of, was used for patterns. Mahogany was probably the preferred wood, particularly if for something that's going to be used for a long period of time. It's fairly easy to work. You can put a lot of detail in mahogany, and even though it's kind of a soft wood, it's a tough wood. It doesn't shrink very much. It doesn't move around very much. And it actually holds up pretty well in a foundry situation. But, I mean, I've seen patterns made out of maple. I've seen them made out of cherry. I've seen them made out of pine. I've seen them made out of all kinds of different things. In fact, pine was actually pretty common pattern material, particularly for short-run patterns where you weren't making a whole lot of them. A little bit cheaper material to use. A lot of it was sugar pine that they used, but any kind of pine can be used. Now, as far as how we're going to make this pattern, in today's world, let me just say this. Back years ago when I first started making patterns for doing machinery restoration, needing castings, pretty much everything was made out of wood. That's how I learned pattern making. But in recent years, I've been using 3D printing a lot for patterns because it's fairly easy. I can just go model it in, hit a print button on a 3D printer and print my pattern out, and voila, we're ready to go. And again, for short runs, they're durable enough, they hold up just fine, and you don't have to worry about doing all the intricate work that's involved in making a pattern. You just put it in your model and it prints it out. Now on this pattern, because of the size, 3D printing is probably not going to be as practical. Most 3D printers couldn't print something this large. There are printers out there that could, but most people that have 3D printers have smaller printers. You'd have to make it in pieces and kind of put it all together, and it's kind of clunky. And anyway, my plan is this is going to be somewhat of a hybrid pattern as far as materials go. I'm going to make the center drum here, the round part in the middle, is going to be made out of wood. The end pieces down here, I'm probably going to 3D print. I'm going to cheat. And again, there's some fairly complex things that has to go on with these, with cores and core prints and stuff like that. It's going to be a lot easier to just model that on the computer and print out these pieces than anything else. Today, what I want to do is get started on this pattern, and we're going to be making the wooden center part of this. So basically what I'm going to end up with is a wooden drum with the shaft down here is going to be turned in there, because we got to have that in the pattern to be able to create a print for the shaft to drop down into. So we're going to be making the shaft in the center drum here out of wood. That's my game plan. And just got to follow along and see how we do it. I've actually gotten out some of my old pattern making books. I've been doing some homework, and I think I got a good plan on how we're going to go about doing this. And I got to figure out sizes and so forth like that. So let's get in here and get started. So when this roller was rebuilt back in the 80s, for whatever reason, and probably because they didn't have the original specifications, they didn't take it back to the size it was supposed to be. Because of that, the owner has told me they've had problems. They've not been able to get the rollers to get to the size that they need to be to properly crush cane. So I've got this book right here, The American Cane Mill, by Don Howard Dean. It's a very good book if you're interested in cane mills. They've got a real good history about all the different makers of cane mills, and they've got a lot of information in here on different mills, and the John Deere Amazon mill is in the book. And there's a chart in here that gives what the diameters are supposed to be. So originally, the diameter of the large rollers were supposed to be 10 inches in diameter, and the length of the rollers were supposed to be 12 inches. Now, 12 inches is going to be on the inside of this. The small rollers kind of fit up into this little groove. When this one was done, they put a sleeve over this, and they actually made the roller larger in diameter than it needs to be. I think they turned it down and then put a sleeve over it. And when I measured this a while ago, it's about 10.8 inches in diameter roughly, whereas it's supposed to be 10 inches. So anyway, I'm going to take that into consideration. This is not original here. You can see where that's been welded in there and that sleeve kind of put up over it. But we'll take that into consideration while we're doing our measurements. This is supposed to be 12 inches from inside to inside. So from the inside of the flanges, it is still 12 inches, actually about 12 and a quarter. And that looks like it's probably original. The other rollers, like I said, are 12 inches. That gives a little bit of wiggle room in there for things to line up properly. So that kind of gives me some information I need. And let's see. This shaft is just a little under 3 inches. Looks like probably 2 inches and 15/16 is what it looks like it's measuring just off the tape measure. I don't know why back in the day shafts were usually like at 16th inch increments. They never went to quarters and halves and all that, but we'll go take it back like it was. So I'm just going to kind of sketch out what we need here for this inside. Like I said, we're going to make the wooden drum. It's just going to be flat across them. We're not going to have flanges on what I'm making right now. That will be on the other pieces that are going to come on this later. Let's see, the total shaft length here, 32 inches. Let me write that down. I think for the purpose of the pattern, we're going to make these journals here 3 inches in diameter. We'll put a piece of 3-inch steel in there when we're doing this, and we'll turn it down to this proper size. That way if there's any kind of warpage or anything that goes on, I'm not expecting very much, but if anything gets out of whack just a little bit, we'll have a little bit of metal that we can kind of true it up with whenever we get ready to actually turn all this stuff and get it turned down to size. All right, let me start doing some sketching here of what we need to do, and we'll get started making this. So I've kind of figured out what I want to make here. This is basically what the pattern that I'm going to be working on today is going to look like. Fairly simple, but yet there's a lot to this. The diameter I want to be 10 1/4 inches. It needs to finish out at 10 inches. I want it to be a little bit thicker so that we have material to remove off of that. So I'm going to add, usually my rule of thumb is to add 1/8 of an inch for machining. Because this is a round piece, I need to add 1/8 of an inch to each side, so that's going to be 1/4 of an inch. So 10 1/4 inches, that'll give me 1/4 of an inch or 1/8 of an inch off of each side to clean up when I put it on the lathe to get it down to the right size. So a little bit larger than what it needs to be, but that's going to allow for the machining. The length of that, I'm going to do 11.875, 11 7/8 inch wide. And again, we're going to have to make some other pieces to come on here for the flanges and all that kind of stuff, but that should give me plenty of room to deal with there, according to what I've kind of got planned. Now, the pieces on the end, again, this is going to basically be the core print. I'm calling it a core print. It's not really a core. We're going to put that shaft in there, but it's going to be kind of like a core in the mold. That needs to be 3 inches in diameter. The total length of that shaft is 32 inches, and it needs to be sticking out 10 1/2 inches from this side and 9 1/2 inches from this side. Those are rough measurements because we're going to have about a little bit of extra in there. We'll just kind of average it out there on that length. So that's what I'm after. And this is going to be a split pattern, so there'll be a top half and a bottom half. And I don't want to make this out of solid wood. It's just going to use up way too much wood. So what I'm going to do is we're going to actually use um, a staving process to give us the wood around the outside shell, but it'll be kind of hollow on the inside of the pattern. I'm going to grab my pattern making book and kind of show you what this looks like. So to make that large diameter drum, we're going to use a staving process here. Basically, there'll be a little end on the end. I'll make that out of plywood. It'll have little sections cut out straight on there. Then we're going to screw in some pieces of wood to that. We'll do two halves, and you can see it'll be kind of out there. And then once that is all put together, glue dried and everything else, we'll put it on the lathe and actually turn that outside diameter to the diameter that we want on my pattern maker's lathe over here. And but that way it won't have to be solid all the way across, and kind of give us something to work with. Like I said, there'll be the top half and the bottom half. But that's kind of what I'm going after. And the next thing I want to do is I want to lay out those end pieces so that we can go ahead and get those cut out, and then we'll cut out our pieces of wood and start putting it all together. Now there's going to be a little block that runs down the center of this, kind of like this right here. You can see that. That'll separate them and give them support, but that's going to actually be about 3 inches square, or 1.5 inches by 3 on each half. And that way, again, I can turn the ends round, and these ends are going to stick out, and that'll be what becomes the little round shaft, or my core print. But then on the inside, it'll be solid, and that'll kind of give us some strength going from one side to the other. Anyway, that's kind of what I'm after. So I think the next thing I want to do is start laying out my my end pieces, my heads, so that we can get the ball started on getting this done. We got some 1/2-inch plywood that we're going to make these end pieces out of, and I'm just going to lay everything out right here on this right here. So I want my finished diameter to be 10.25 inches in diameter. That's will give us room to machine it off. But I want the actual piece that I'm making to be 10.5 inches. So again, that gives me a little bit of material to cut off on the lathe to get it round. So anyway, 10.5 inches is what we want to do. Now, one thing I'm going to talk about right now is that we need to take into account shrink factor. I talked a little bit about before about this shaft, how whenever the cast iron cools in the mold, it's going to shrink, and it's going to kind of pull up on here and make a really tight fit. But that shrinkage is also something we got to take into consideration when we're doing our measurements here, because cast iron is going to shrink. Whenever you put it in the mold, molten hot, when it cools down, it's going to become a little bit smaller. Now, shrink factors are going to vary depending on foundry and material that you're doing. I know from experience and talking with the foundry that I'm working with, the cast iron that I'm doing shrinks at a rate of about 1/8 inch per foot. So for every 12 inches that you make something, if you make it exactly 12 inches on the pattern, after it cools, it's going to be 1/8 of an inch shorter than that. So you kind of factor that in. Now, pattern makers, the way that they got around this is they had what's called shrink rules. And I've got a bunch of shrink rules right here. These are a bunch of different shrink rules with different shrinks in them for different materials. And the interesting thing is, I'm gonna zoom in and show you this, but these are all 12-inch rules. I got a 24-inch one right here, but they're all different lengths. But they look like a regular ruler, but they're all different lengths. Let me show you up close. So this ruler right here is exactly 12 inches long. This is a true 12-inch ruler, and when you put it up on top of these, it's shorter than any of the other rules. And if you look, I got a bunch of them that have different shrink factors. They're all the same length on this end down here. They're all butted up against that bottom square, but each one of them is a little bit longer. And each one of these takes into account a shrink factor. So the one on the top, that happens to be the one we're going to be using. That's 1/8 inch per foot. So basically, when you look at this, this ruler is 12 inches, which is a foot. That ruler here is 1/8 of an inch longer. So again, If we use this ruler to measure by, it automatically takes into account the shrink factor. So it automatically, every single one of my measurements is just a little bit larger than what it needs to be. This is what pattern makers use. You got to make sure you're using the right shrink rule, and you got to make really certain that you pay attention if you got shrink rules in your shop, that you don't go pick one of these things up and think that it's a regular ruler if you're making something, and it's not going to be the real length. That was a common trick that they used to pull on apprentices back in the day, is they'd hand them a shrink rule and nothing would fit right. This one here happens to be 1/10 of an inch per foot. There's all kinds of different shrinkages in here for different things. 3/16 inch per foot. This one is also 3/16. This is 1/4 inch per foot. 9/32 per foot. 5/16 per foot, 11/32 per foot, and 7/16 per foot. So I got a bunch of these. I'm gonna put the ones up that I'm not gonna use. I'm gonna put this one up over here because that one's a true 12-incher. And again, I also have a 24-inch one. This one happens to be a wood one. And they're typically gonna say on here, 1/8, shrink 1/8 inch per foot. It says right there, shrink 1/8 inch 2 foot. So that tells me which one I'm using. But I will be making my measurements using this, and they'll all be a little bit larger, but they'll come out to the right size in the end. So first thing I'm going to do is I want to swing an arc on here that's going to be 10.5 inches in diameter. Half of 10.5 is going to be 5 1/4. So probably have to put the beam on here. Let me get this set up. And I'm setting my radius to 5 1/4 inches. And what I'm going to do is I'm going to come in off leave me a little bit of room on the end down there. Just swing me over and up an arc. We're going to kind of put the compass right here on the edge of the table. Whoops. All right, so there's my outside diameter, and let me mark my center. Let me go grab some squares, and I need to kind of start segmenting this out. All right, so I'm going to take a machinist square, and I'm just going to kind of work right off of that center. We'll draw a segment up that way. Now I want to do 30-degree segments coming off of this, so I'm just using a 30-degree triangle here. And we'll do the same thing on this side. Then I also need to do the 60 degrees, which will be another 30, which will be this angle. There we go. So basically what I want to do now is have a piece of wood that's going to be tangent to that. Let me figure out how I'm going to do that. I'm just going to draw a straight line between each one of those on that arc. All right, I'm just going to measure this. What I'm looking at is, I drew this straight line across here because I could get a nice isosceles triangle. Theoretically, my legs should be the same, but it needs to be a little bit higher there. I'm actually going to go a little bit more than that, so we're going to just do it. Tell you what, we'll do 1/8 of an inch or 1/4 of an inch rather. So I'm going to come in here and I'm going to make a mark on each of these 1/4 inch above the line I got on there. Now I'll bisect those. That's just showing where the top of my wood needs to be to give me the clearance for that arc so we have enough wood to turn it out. Now I know that the thickness of my 2x4s are 1.5 inches roughly. Now this is not a shrink rule, this is just a regular rule here because my 2x4s were not shrinking. But I know that again they're 1.5 inches, so that's basically the thickness of my 2x4s. I'm going to come in here and measure each one of those. All right, so this is basically my end cap. This would be the 2x4s that I'm going to have to cut out on the table saw with the 30-degree angles on the bottom, and I can just come in here and measure that, get the actual measurement for that. I'll go around and check them all to make sure they're all the same. Basically they're 2 1/8 inch across that bottom. And I also need to notch out for the 3-inch piece here in the middle. I think I'm going to make that 3 1/4 inches. Just give me some wood to work with. So 3 1/4 would be 1 5/8 on each side. And up 1 5/8. All right. So I need to cut out, I'm going to cut out one of these, use it as a template. I'm going to lay out some more on my plywood. I'm going to need 3 for each side, 1 on each end, and I'm also going to put 1 in the center just for good measure. Probably doesn't need the 1 in the center for the short span that we're doing, but hey, if it's worth doing, it's worth overdoing. So, all right, so again, I'll cut out my 2x4s that will kind of work around these, and we'll cut out our end pieces. I'm over here at my 36-inch crescent bandsaw. We're going to go ahead and just kind of cut this out, and I'm going to leave the line on there, and we'll go over to the belt sander and kind of sand it down to get it right where it needs to be. But let's go ahead and get this cut out. Start this up. I'm just going to start by just cutting that out into a smaller piece that I can manage a little bit easier. There we go. And I'm working on this line right here, and again, I'm going to leave the line on there. We'll stop the saw and get that little piece of wood out of there. I don't want to put my fingers in there too close to it. And now I want to cut out the notch for the piece in the bottom. I'm going to cut this right to the line. It's a really wide blade. It doesn't give me a lot of radius to swing around to cut getting that bottom. I'm just going to kind of nibble it out here. All right, I think I can get in there now. All right, let's go to the belt sander and dress that up. Got my Porter cable belt sander here. We're going to sand these right to the line. So I'm going to lay out some more of these. I'm just going to use this little 2x4 as a fence down here on the bottom. I got it butted up against the bottom of this piece of plywood, and then we'll butt this up against it as well. And I'm just going to go around it and trace this out. And I need a total of 6 of these. Oh, I need to do the center too. All right, ding dong. All right, we'll do 6 of these, and we'll go cut them all out. And that's it, 1, 2, 3, 4, 5. I've already got 1, so 5 more will make 6. All right, I'm gonna go cut these out. We'll do the same thing. So I think we've got our little end caps, and we also got a little centerpiece. This is laid out approximately the width they'll need to be. I still need to get my piece of wood that this is gonna have up underneath it made, and these set down on there, all that done. But we've got our bracings done. The big thing is getting the layout done so that I kind of knew how to do this. And we just did it on, did it on the piece of wood that we were gonna cut it out from, and it is what it is. So anyway, up next, we'll have to make the centerpiece in here, cut our staves, get it all glued together and put together, and then from there, get it over and turn it. But for today, I think this is about as far as we're going to be able to go, just because I'm running out of time, which seems to happen a lot. So we're going to cut off here and pick up on the next one and get the centerpieces and the staves put on. Well, guys, there you go. That's going to be a wrap for today. I hope you're enjoying this. This is a little bit something different than what I normally do on my channel, but pattern making is definitely something that has to be done sometimes when you're doing restoration work if you want to cast new parts, which seems to come up a lot in my shop. So with that, guys, we are going to get out of here. We'll catch you on the next video. As always, thanks so much for watching. Please subscribe if you haven't already. Thumbs up and comments, always greatly appreciated. It helps out with the algorithms on YouTube. Big, huge thank you to those who support the site financially through Patreon, PayPal, etc. It really does help out a lot. And with that, guys, we are going to get out of here. Like I said, we'll catch you on the next video. Again, thanks for watching.